So there's two parts to this question. I'm going to answer them together. I think that'll be a better way of explaining this. So we want to draw a circuit so that we can measure the EMF and internal resistance of a cell. And then we want to talk about the actual experiment behind that. So how would we use a graph to do so? And what would be our method? So if we first think of the equation EMF is equal to terminal potential difference plus current in our circuit multiplied by the internal resistance. If we rearrange this equation for V, the terminal PD, so V is equal to, I'm going to change the order of this and write it as minus Ri plus epsilon. This is of the form y is equal to mx plus c. So then if we were to plot a graph and have the terminal PD on our y-axis and have the current in our circuit on the x-axis, this will be a straight line with a negative gradient, and the gradient would be minus r, and the y-intercept would be the EMF. So if we can find a way to measure our current and our voltage in our circuit, the voltage is the terminal PD, so we'll need some kind of voltmeter in parallel with our cell or our external resistor or external load. And then we need an ammeter in our circuit as well to measure current. We also need a way of changing the current and voltage in our circuit, and then we can plot this graph. So then the things that we would need a variable resistor, and that would be how we would change the voltage and current in our circuit. We need our ammeter to measure the current, and then we also need a voltmeter in parallel with either the cell or the external load. It's the same thing, has the same effect. So this would be our answer to part A. And then for part B, it's just describing what we were talking about. So change the external load, and then using a voltmeter and an ammeter, measure how the voltage across that component and the current in the circuit changes. And then plot a graph of V against I, so terminal potential difference against current in our circuit. And our gradient would be the negative of the internal resistance, and our y-intercept would be the EMF.